Questions on your screen may seem difficult, but I can assure you that by the end of this video, you'll be able to solve all of these and more. Alright guys, a very good morning to you all. You see, in exams, it is a general tendency to leave questions of logs, thinking that they'll be difficult and we won't be able to solve them easily. Here today, we'll understand the basic properties of logs and learn to differentiate logarithmic functions and also find derivatives of logs. First, let's refresh our memory about what are logs. We'll use three terms repeatedly in this lecture: base, power, and value. The concept of logs is based on these three terms only. See, if you are given a base and you raise it to a certain power, you get a value. For example, 10 to the power 2 is equal to 100. Here base is 10. You raise it to the power 2 and you get the value 100. Similarly, 10 to the power 3 is equal to 1000. Here base is 10 again, power 3, and value we get is 1000. You get the point. Therefore, if a to the power x is equal to y, where a is the base, x is the power, and y is the value, then the power x is called the logarithm of the value y to the base a, spoken of as log of y to the base a. So now 10 square is equal to 100 implies log of 100 to the base 10 is equal to 2. Similarly, 10 cube is equal to 1000 implies log of 1000 to the base 10 is equal to 3. The way to remember this is when you write the equation a to the power x is equal to y in logs, you just interchange the power and value in their places and retain the base as the log base. X and y interchange their places and the base a becomes the base of log. Easy peasy. Now let's see the basic properties of logs, which we'll use extensively in differentiation. Now let's see the basic properties of logs, which we'll use extensively in differentiation. Number one is what we also call the product property. Log m into n to the base a can be written as log m to the base a plus log n to the base a. Here m and n represent the arguments of log. These can be any positive number or variable. Also, it is important to note that the normal log base is taken as 10. If it's natural log, the base is taken as e, which is the Euler's number. Let's take an example. If we are given log 2 into 3 to the base 10, we can write this using the above property, that is the product rule, as log 2 to the base 10 plus log 3 to the base 10. Here m and n are 2 and 3 respectively, and the base is 10. Now let's check from the log tables. Log values in the table are by default to the base 10. Okay, so log 2 is 0.3010 from the tables and log 3 is 0.4771. If we add these two, it means log 2 plus log 3, we get 0.7781. If you check for log 6, because this 2 into 3 is equal to 6, you get the same value, 0.7782, roughly the same. So memorize this property as it will be used a lot when we'll solve our questions. Let's move on to the second property called the quotient rule. Log m divided by n to the base a is equal to log m to the base a minus log n to the base a. In the product rule it was plus, and in the quotient rule it becomes minus. You can verify the same by taking values for m and n as we took earlier and check using log tables. These are all simple properties and are used extensively when we solve log problems. So just memorize them. We'll use them as it is. Third property is the power rule. Log m to the power n to the base a can be written as n. This power n comes and becomes the coefficient, so n into log m to the base a, right? So this is very important. Log m to the power n to the base a is equal to n into log m to the base a. Okay, so the power becomes the coefficient. Fourth is the log of 1. Log 1 to the base a is equal to 0. इसको बहुत easily check भी कर सकते हैं. See, in the introduction of this video we saw that log is basically the inverse of an exponent. That is, if a to the power x is equal to y, then log y to the base a is equal to x. यही देखा था ना हमने. भूल गए हो तो एक बार फिर से इंट्रोडक्शन पार्ट ऑफ दिस वीडियो देखो. We know that any number raised to the power 0 is equal to 1, right? Therefore, in a to the power x is equal to y, if you take this power x as 0, you get a to the power 0, which is 1. So, if you put x is equal to 0 and y is equal to 1, in this equation, log y to the base a is equal to x, you get log 1 to the base a is equal to 0, which proves our fourth property. Fifth property is log e to the base e is equal to 1. Remember this as it is. Sixth property is log e to the power u to the base e is equal to u. Here u is any function of x. Remember this one as well. So these are the 6 properties that you see on your screen. We will use all of these extensively in solving questions on derivatives of logs now. First is, if y is equal to log x to the base a, then the derivative of y, how do we write the derivative? Dy by dx. Then the derivative of y is dy by dx is equal to 1 by x into log e to the base a. ये प्रॉपर्टी बहुत ज़्यादा यूज होती है. याद रखो, if y is equal to log of x to the base a, then the argument of log, in this case x, becomes an inverse coefficient, that is 1 by x multiplied by log e. See, here we have log x to the base a. If base a is not given, then the default base we take in derivatives of logs problems is e. Means if only log x is given, it is read as log x to the base e. Look at this second derivative property as an extension of the first one. If y is equal to log of x, here we have removed the base. So if y is equal to log of x, if you see, this is exactly same as the first property, just that the base is not there. So if y is equal to log of x, here base is not given, so we take it as default e. It becomes y is equal to log of x to the base e. The derivative of y here will be, क्या आएगा using the above derivative property? dy by dx is equal to 1 by x into log e to the base e. पहले log e to the base a आया था, because a as a base was given. In this the base is not given, so log e to the base e. कुछ भी नहीं किया, हमने ऊपर वाली डेरिवेटिव प्रॉपर्टी यूज की है. Here the base is e, so a की जगह e आ गया. Now what is log e to the base e? अभी हमने देखा था in properties of logs, it is 1. Log e to the base e is equal to 1. Therefore the equation becomes dy by dx is equal to 1 by x into 1. Log e to the base e की जगह हमने 1 लिख दिया. So simplifying it becomes 1 by x. dy by dx is equal to 1 by x. So if y is equal to log of x, dy by dx is equal to 1 by x. Simple. Let's move on to the next derivative property. Till now we were taking the argument as x. If instead of x a function of x is given, let's assume u is a function of x, that is u is equal to f of x. Now we are given y is equal to log u to the base a. Here the derivative dy by dx is equal to 1 by u, because argument becomes the coefficient in inverse, so 1 by u into log e to the base a. Now we'll differentiate u as well. Remember the chain rule that we did in one of the previous lectures. So our complete derivative becomes dy by dx is equal to 1 by u log e to the base a. यहाँ तक तो first property से आ गया. Then chain rule into du by dx. U is also differentiated further. If base a hadn't been given, then our derivative would have been simply dy by dx is equal to 1 by u du by dx, because log e to the base e would have come and it is equal to 1. Easy peasy. Quickly see the derivative properties on your screen, then we'll move on to questions. Perfect. Now let's solve some questions. We saw 7 questions in the beginning. Let's solve them one by one. Y is equal to log 2x square plus 3x plus 4. If you see here, this is of the form y is equal to log of u, where u is the function of x, that is 2x square plus 3x plus 4. We know that if y is equal to log of u, then the derivative of y dy by dx is 1 by u into du by dx. Therefore, we get dy by dx is equal to 1 by u, which is 2x square plus 3x plus 4, into d by dx of u, which becomes 4x plus 3. So our answer is dy by dx is equal to 4x plus 3 divided by 2x square plus 3x plus 4. Simple. Let's move on to the second question. Y is equal to log of x. Y is equal to log of x. Here we can take this log x as u. It is a function of x. So what we get is y is equal to log u. Dy by dx is 1 by u into du by dx. So what we get here is dy by dx is equal to 1 by log x, which is 1 by u, into du by dx. So in place of u we write log x, d by dx of log x. So 1 by log x into 1 by x, because d by dx of log x is 1 by x into log e to the base e. This was the property that we just did. D by dx of log x is 1 by x into log e to the base e, and log e to the base e is what? 1. So d by dx of log x is 1 by x. So we get 1 by log x into 1 by x. Simplifying it, we get 1 by x into log x, which is the answer. Let's take another question. Y is equal to log of log x. So this question appears difficult because so many logs are there, but you will see how easy it is. So the innermost log x we take as u, which is the function of x. Whenever such questions come, whichever is the innermost part which has x in it, we can take it as a function of x and substitute it with u. So we are left with log of log u. Now log u take as v, another variable. Okay, so v is a function of u, log of log u. So what we get is y is equal to log v. Alright, now let's simplify it. Take the derivative. Dy by dx is equal to, since this is log v, so the derivative comes 1 by v into dv by dx. Right, now replace v here with log u. So 1 by log u into d by dx of log u, right? Writing it further, 1 by log u into d by dx of log u is 1 by u into du by dx. Substitute the value of u here, 1 by log of log x into, write the value of u, 1 by log x into d by dx of log x. So we get 1 by log of log x into 1 by log x into 1 by x, because d by dx of log x is 1 by x. Finally we get 1 by x log x into log of log x. This is the answer. Alright, let's see the next question. Y is equal to log of under root of x cube plus 1. Now let's take under root of x cube plus 1 as u. And the derivative of y dy by dx will be 1 by u into du by dx using the property. So what we get here is 1 by u. U is under root of x cube plus 1 into d by dx of under root of x cube plus 1. 1 by under root of x cube plus 1 into, now the derivative of under root of x cube plus 1 is, here if you see x cube plus 1, we can write this as x cube plus 1 raised to the power 1 by 2. So we get 1 by 2. We are using the power function rule. 1 by 2 into x cube plus 1 raised to the power 1 by 2 minus 1, which is minus 1 by 2, into the derivative of x cube plus 1, which is 3x square. Simplifying it, we get 3x square over 2 into under root of x cube plus 1 into under root of x cube plus 1. So this is 3x square divided by 2 into x cube plus 1, right? Let's see the next question. Y is equal to log of x plus under root of x square plus 4. So we take x plus under root of x square plus 4 as u. We get y is equal to log of u. So now you know dy by dx is equal to 1 by u into du by dx. So we write here dy by dx is equal to 1 by u, which is x plus under root of x square plus 4, into the derivative of this x plus under root of x square plus 4. The derivative is 1 plus 1 by 2 into x square plus 4 raised to the power minus 1 by 2 into 2x. We are just using those rules, the power function rule, the extended power function rule, chain rule, etc. Alright. So the next step, 1 by x plus under root of x square plus 4 into 1 plus x by under root of x square plus 4. This minus 1 by 2 comes in the denominator, becomes positive. Let's open the bracket. 1 by x plus under root of x square plus 4 plus x by x plus under root of x square plus 4 into under root of x square plus 4. So taking the common denominator, x plus under root of x square plus 4 into under root of x square plus 4, and in the numerator we get x plus under root of x square plus 4. These two cancel out, so we are left with 1 by under root of x square plus 4, which is the answer. See the next question. Y is equal to log of 1 plus 1 by x square. Taking the derivative, dy by dx is equal to 1 by 1 plus 1 by x square into d by dx of x square plus 1 by x square. Okay. So if you see here, 1 plus 1 by x square can be written as x square plus 1 by x square. We can take these as two separate functions, u by v. So x square plus 1 is u and x square here is v. And we apply the quotient rule here, v du by dx minus u into dv by dx over v square. So we get here x square over x square plus 1 into v, which is x square, into d by dx of this x square plus 1 is 2x, minus u, which is x square plus 1, into dv by dx, which is 2x, over v square. So v is x square whole square of this. So we get x square over x 4 into x square plus 1, and numerator 2x cube minus 2x cube minus 2x. These two cancel out, x square and x4 cancel out, x square is left. We get minus 2x over x square into x square plus 1. X and x cancel out. We get minus 2 over x into x square plus 1. See the next one, y is equal to under root of log 3x square plus 7. We can write this as log of 3x square plus 7x raised to the power 1 by 2. So dy by dx is equal to, we'll use the power function rule. If y is equal to ax plus b raised to the power n, we get dy by dx is equal to n into ax plus b raised to the power n minus 1. And the derivative of ax plus b is a. So multiplied with a. So we get dy by dx is equal to 1 by 2 into log of 3x square plus 7x raised to the power n minus 1, which is 1 by 2 minus 1, into 1 over 3x square plus 7x into 6x plus 7. So we get 1 by 2 into log 3x square plus 7x raised to the power minus 1 by 2 into 6x plus 7 over 3x square plus 7x. Simplifying it further, we get 6x plus 7 over 2 into 3x square plus 7x into under root of log 3x square plus 7x, which is the answer. Let's see this question. If y is equal to x by 1 plus log x, then what is dy by dx? Alright, so here also we take y as u by v. Okay, so the numerator x is u and the denominator 1 plus log x is v. And we know if y is equal to u by v, then dy by dx is equal to v into du by dx minus u into dv by dx, whole of this over v square. So when we write it here, we get dy by dx is equal to 1 plus log x, that is v, into du by dx. So d by dx of x is 1 minus x, which is u, into d by dx of v, which is 0 plus 1 by x. Whole of this over 1 plus log x whole square. This x and x cancel out. So we get 1 plus log x minus 1 over 1 plus log x whole square. Simplifying it, we get log x over 1 plus log x whole square, which is the answer.